So Tuesday, Wednesday, all about absolute values and solving equations. Now we remember from our function family activity, absolute values, those are the ones that have the graphs that make the corner. They look like the V, okay? Absolute values most commonly used with distance, because we've talked about distance a little bit, but if you have distance, right? If we walk from here to the door, is that a positive or a negative? You talk distance. Think about miles in your car, right? You drive somewhere in your car, drive from here to home, it's still positive, right? But then you get up in the morning, you drive the exact same route from home back to school. Is that positive or is that negative? That's positive again, right? Distance is always positive because we're always going somewhere. And that's why these things come through. So when we talk absolute values, it's first good to kind of review this basic setup here because it helps us solve the equation. So first off, I want to figure out what number I can put inside here for x and get out 7. Well, we know one of these answers. That x can be positive 7. Absolute value makes everything inside of it, the result of everything inside of it turn positive. So the absolute value of positive 7 is 7. What else can I put in there? I'm going to put negative 7 in there. Meaning that when we look at the value of x that can be in here, if we were to solve this, and we're going to get some notes and kind of go through this in a second, there's 2 answers. That x, because it's inside that absolute value, that x can be 7 or it can be negative 7. Both of those will solve that equation. And this is an equation because it has an equal sign. The same thing happens over here. We know that the number inside here needs to be 8 or negative 8 to make these 2 things true. So what that means is, that this 2x can equal 8, or it can equal negative 8. And what's going to happen is, if we wanted to figure out x, I think you could figure out x. X for this one would be 4 or negative 4, right? We can kind of look at that one and figure it out. But what are we actually setting up and solving? Well, to get this 4, we're saying that these 2 things need to be equal. 2x would need to equal 8. That's how we got to the 4. Or 2x would need to equal negative 8. That's algebraically how we got to the negative 4. And you see where we're building to this. As these expressions inside the absolute value become a little bit more complex, we get a little bit longer answer. Meaning, I know that this expression inside, this 2x minus 4, I know that the result from whatever I get in here can be either positive 2. I'm sorry, let me go back. I forgot I set this one up on myself. Rewind. Can that ever happen? Sorry, I forgot I set myself up like that in the beginning. Look at that, I made an error. Why can't that ever happen? What type of answer is this? That's negative 2. So what it's asking us, forget about this stuff inside. What can I get in there inside an absolute value that'll result in a negative? Nothing. No solutions is one that we like for this one. Because absolute value will never yield a negative result from inside of it, meaning any result that's trapped inside of it, like we saw with this 2x, everything else, anything that's left inside of it, when you lose the absolute values, you must be positive. So since it must be positive, we can get 2 answers. We can get no solutions. Sometimes we can get 1 answer, which is weird. But those are the 3 kind of flavors that answer comes in, okay? Now I have some notes that we're going to go over, but really just kind of for the example-wise, okay? So when you go through and you solve an absolute value, what you need to, and you don't need to necessarily copy these in class, guys. I'm gonna upload a copy of these later for you, okay? I think they're up there, but I might have missed them with my file upload this week. Biggest thing is there's a possibility for 2 solutions to every problem. All right. Now the key with this, when you get an absolute value, you got to isolate the absolute value first, okay? Meaning that we could have other stuff taking place outside of the absolute value. You need to think, think of our transformations. Our A transformation was outside of the absolute value. Our K transformation was outside of the absolute value. You'll have to algebraically move that stuff to the other side of the equal sign so that you can solve it, okay? So the first step in this is always going to be isolate the absolute value. Get it? So it's just the absolute value and whatever's trapped inside of it on one side equal to a number. And then we're going to rewrite the equation twice, getting rid of the absolute value symbols. We're going to make one equal the positive answer and one equal the negative answer. We're switching the positive negativity of the single answer on the outside. And then solve each one of them just like you would a normal equation. They're both possible answers for an absolute value. Let's try one this way. So let's look at this one. So do write this one down with me in class, guys. Because this is probably about as complex as this type of problem will end up. Now, why I think this one will probably be the most complex is because of the way this is written. Because we usually don't see that -8 up there in the front of that -2. We usually see this written after the absolute value, the way that we had seen the transformations. But we need to work this down so that we just have 5x minus 7 equal to a number so that we can split this up. So that means we need to use our algebra skills here to get rid of this stuff. This -8 is the hard part. This -8 is subtracting. How do you get rid of a subtraction? You got to add it. So we're going to take this and we're going to add it to this side. So that leaves us -2 times the absolute value of 5x minus 7 is equal to -6. Now, one of these two, don't jump until you get this thing isolated. Don't jump to the conclusion that there's no solutions. Because even though this was negative, like we saw in that first example, what happens when we get rid of this 2? How do you get rid of this 2? What is it doing to the absolute value? Adding, subtracting, or multiplying? It's multiplying. So we're going to divide this thing. That'll make this go away and give us our isolated absolute value. But what is -6 divided by -2? Is it positive or is it negative? It turned positive. So before you jump to a conclusion like we did all the way back up here where we said, hey, this has to be positive, make sure that you've isolated the absolute value, because when you do the algebra that we saw right here, we could end up getting a positive even though it looked negative when we started. Okay, so always isolate the absolute value before you look for that. So now we have a positive number, we have the absolute value isolated. We're going to write 2 equations to solve. The absolute value bars go away. We just get 5x minus 7 because we know what we want to result from that can either be a +3 or -3. if I do these operations, whatever number I plug in for x, if I get positive 3 out, that'll make this true. If I plug in an x and I get negative 3 out, that'll also make this true because of the absolute value. Solve them independently. Solve one, then solve the other. So we're going to add 7. All I'm going to do, this is just normal solving a linear equation. Divide by 5. And that x is 2. We do the same thing here. Add the 7. So we get 5x is positive 4. So then x is 4 over 5, which is also 0.8. Either one's fine. You could leave it as a fraction or you could write it as a decimal if it comes out terminating. All right, let's work these two examples then. So first step is always, before you can determine whether you're going to have answers or not, isolate your absolute value. So we're going to get rid of this 6 first. And writing it out front makes it a little tougher, but it's adding, so we're going to subtract it. So that's going to give us 4 times the absolute value of 2x minus 4. And let's see, this gives us 8. We'll divide the 4. And that gives us 2. So that means we're going to have answers because we got down to just the absolute value and we have a positive result. So that means this one does have 2 answers. So we're going to go 2x minus 4 equals positive 2. That's one of my solutions. And 2x minus 4 equals negative 2. We're switching the sign on this answer part over here. And then we'll just go ahead and solve. So that's 2x equals 6. So that one's 3. And we're going to add this. So that's 2x is positive 2. And 2 divided by 2 is 1. So that one is 1. Put a little arrow together, you get it. They're both the answers, okay? So you would list, you could say x equals 3 and 1. But that would be fine. Just show me the work for both of them would be adequate as well. All right, let's do our second one over here. So we're going to add this 3. So that's plus 3 and plus 3. So we get negative 2, 2x plus 3 equals 5. Now we're going to divide by negative 2. That'll cancel that out. And that gives us negative 2.5. So if we check, we got the absolute value isolated, but because this number right here is negative, what does that mean? That means no solutions. Anytime we get it, just an absolute value equation equal to a number, that number has to be positive. If we get a negative, that's not going to work. Absolute value doesn't yield any negative. So the answer to this one is no solutions.